All process data can be shown on the display of the SIEMENS 4 device. Our example shows an overview of the primary working values. It goes without saying that as long as no measured currents are flowing, all displayed values are 0. There also won't be any network failure indications or fault records yet. To change this, you need to simulate a fault. For this purpose, you need a test device to replace the secondary side of the current transformer. Set up a 3-phase connection between the test device and the current input of your SIEMENS 4 device. In order to be able to share a return line, connect the still open current inputs on the left side of the terminal to current links. Set the test current to the value of the nominal device current. The device must not be tripped at this setting. As you already know, you can find the nominal current in the data on the rating plate. Now slowly increase the current to double the nominal value in all 3 phases. A visible reaction is the lighting up of several LEDs, including those that are linked to indications for general excitation and tripping. At the same time, the output contacts to which these indications are routed are audibly closed. If your SIEMENS device has a small display, additional indication texts are also displayed. The type of indication buffer your SIEMENS device has depends on the individual model. The indications generated as a result of the simulated network fault are stored on the fault indication buffer. To display these indications, navigate through the individual menu levels in the usual way and select the relevant fault. Read the indications clearly and conveniently with DIGSI 4. For example, with just a few mouse clicks in the menu tree of the device editor, you can display all operational indications currently in the device. If required, you can store the displayed indications, which will mean they're also available in offline mode. Measured values can be displayed and stored in the same way as indications. Reading fault records is just as simple. If you've installed SIEMENS 4, simply double-click the relevant entry in the list view to display the fault area. SIEMENS 4 displays the measuring signals as either time signals, vector diagrams, circle diagrams, or bar charts. DIGSI 4 offers a range of test functions. As an example, we would like to demonstrate the function hardware test. This allows you to check the functionality of the binary inputs, binary outputs, and LEDs of your SIEMENS 4 device directly on your PC. In this case, all routed indications are actually transmitted. For example, to switch on a deactivated LED, click On in the display dialog. Before DIGSI 4 takes any action, you must first re-enter the relevant password. All further actions are then executed directly. After the command is transmitted, the display in the dialog is updated. Of course, you can monitor the effect on the device. Please note that when testing binary outputs, the change actually occurs at the SIEMENS 4 device, meaning switching operations are actually executed at the binary outputs of connected equipment, such as circuit breakers. Equipment can be controlled directly at the SIEMENS 4 device. All switching operations are safeguarded with factory predefined interlock conditions. First, place the upper key lock switch in the local position. Press the Control key to bring up the control display. Use the arrow keys to move the selector to the symbol of the circuit breaker. Then press the On button and confirm with Enter. A confirmation box appears on the display, which must be confirmed by repressing the Enter key. A message appears telling you that, due to the parameterized field interlock, switching is not possible. Press Enter again to clear the message from the screen. To try out the switching function anyway, use the key lock switch to switch to test mode. Now repeat the steps described previously. As soon as you've acknowledged the displayed confirmation box, listen for the typical relay noises on the device, which is an indication that the binary output has responded. Because the corresponding binary inputs for the checkback signals of the circuit breaker have not been wired, there is no checkback signal. That's why a message appears on the display reporting checkback timeout. For this reason, the display for the circuit breaker is not updated. As you can see in our example, your Cyprotec 4 device already has preset interlock conditions. However, you can easily change these to meet your requirements. To do this, use DIGSI 4 in conjunction with a CFC editor. Start the CFC editor directly from the DIGSI device editor. You can now change existing interlocks or create your own. You will find more detailed information on this subject in the documentation for the CFC editor.